So we were discussing that signal warrant analysis problem, and we had the traffic volume. We were looking at that those signal warrants sheet there. So the question then was, let's see where. So does it actually meet the peak hour warrant first of all? So if you look at that problem that we were dealing with in our that I shared with you, does that actually warrant a traffic signal? Okay, I did share the problem sheet with you. So the problem that we were dealing with, let me open that sheet up. This. There's the warrant one. We talked about warrant one, warrant two, and warrant. So let's talk about quickly warrant three. So in peak hour warrant, I told you that this is not something that's my favorite. I don't think just 1 hour should be the basis for just putting in a traffic signal anywhere, unless it's a safety issue. And we were just having some discussion at the end of the class the other, like just kind of walking by the corridor. The idea is that, at least sort of obviously, they leave a lot to your judgment. And your judgment, and I don't want to necessarily influence it right this minute, and it will be context specific and everything. But just sort of getting started point, I would say that we should be looking at, or we should be thinking about, if it's a safety problem, your judgment should be towards, or your initial sort of bias is not quite the right word, but your initial inclination to be using, your initial inclination should be towards installing a signal if the problem that you're trying to deal with is safety. So if the warrant is barely meeting, especially from a safety perspective, yeah, your inclination should be, yeah, we should put a signal there. The safety is a critical goal. Now, if it's an operational issue, like if it's high traffic demand and that's just causing some delays and stuff like that, then potentially I would say that you may lean towards not installing the signal, right? So I think, so that's sort of is a good way to think it about in your head, is a good idea. Again, in the test, if I give you an open-ended sort of problem, I think as long as you communicate what your judgment there is, and you're just not sort of, just kind of picking one option and you're not telling me why you're picking something, that would be an issue. But if you just tell me what is your thought process there, I think you'll be fine. We have a small enough class. I can grade whatever you put in your tests and exams. So I would be looking carefully at that. So I'm fine with that. So if that's something that, so that would be a good, but again, if your judgment sort of goes the other way, but you are aware of it, your conscience is about it, that's okay too. I'm not saying that judgment, like, if you sort of install a signal when you're just barely meeting the warrants on operational side, you decide to put a signal, that's okay too from a points perspective. But I think from a good traffic engineering perspective, maybe you want to be, not be sort of in a place where you're just putting signal willy-nilly. Okay, so that's something that is usually a good idea. Let's quickly talk about the peak hour warrant. I think the biggest thing for me in the peak hour warrants is what's the relationship? What are you looking for in terms of when you look at the thresholds? If you look at the chart between the 8-hour chart table that you saw versus the 4-hour chart table that you saw, and versus the peak hour chart table, do you see a clear relationship between the three? What's happening between the thresholds for 8 hours versus the thresholds for 4 hours and the threshold for peak hour? Do you see clearly the thresholds? What's happening to the thresholds? They are going up or down as you move from 8-hour warrant to a peak hour warrant. They go up, right? Which makes sense, I hope, for everybody. For 1 hour, conditions have to be pretty bad for you to consider a traffic signal, right? But for For 8 hours, if they're moderately bad for 8 hours, then that would be sufficient warrant for you to put a traffic signal. Okay, so peak hour warrant, let's quickly go through it. 4C4, again, not my favorite warrant. A lot of DOTs have moved away from it. And you should probably not worry about it. Again, MUTCD doesn't say anything about it, but a lot of engineers do not consider the peak hour warrant. But let's go through this for our problem that I shared with you last time. Let's take a minute to see if we are meeting the peak hour warrant or not. Again, look at the support and then look at the standard. The need for a traffic control signal. So I'm looking at 4C4 paragraph number 3. 4C4 paragraph number 3, and I probably should open the traffic signal warrant module here as well. 1 second here. So this is the warrant handout. So the one that I'm reading from is right here, 4C4 and paragraph number 3. So let's go back and so here we are, 4C4, paragraph number 3. Okay. So first thing it says, signal sharing should be applied only in unusual cases, right? So they already are talking about it. You know, it should be unusual cases such as office complexes, manufacturing plant, industrial complexes, or high occupancy vehicle facilities that attract or discharge a large number of vehicles over a short time. So HOV vehicle facilities, that will be your trucks. I mean, yeah, that will be sort of your buses, right? So if you're basically right outside a bus depot, and then, you know, so those are the situations where you want to be applying that. So that's pretty important right here. The need for a traffic signal shall be considered if an engineering study finds that criteria in either of the following 2 categories is met. So there are 2 categories, A or B. So it's either of those. And then within A, it's all 3 of those. So it's pretty confusing. So that's why you have to be very careful about as you're applying this. So for example, they're saying either A or B, but within A, it's not one of those 3. It has to be meeting all 3 of those. Okay, so but that's my question for you. So in the example problem that I supplied last time, please let me know if you're meeting the peak hour warrant. So let's take maybe next couple of minutes, look at that warrant and see if it's meeting that warrant. Extras of the. Oh, okay. So let's see. Let me see. Yeah, and also I might have some expense there. Let me see. So you're looking, so, but you have the signal warrants though, right? Yeah, you have the warrants, right? So let me see if I have an extra copy of this because I have. So the problems is in the notes, but you probably don't have the notes. Okay. So reservoir volume by power. Yeah, let's take a look at this. That's fine. Yeah, you can take this. So this is the major and minor approaches. Now maybe take the peak hour one as well. I think I should have that. I can pull it up from the computer, so that's fine. Yeah, these are all numbers, so it's fine. You don't need these. So, and then maybe this is the collision diagram, so you can take this as well. Yeah, you that's all you need. You don't need that. So, yeah, of course. If I have an extra. So we are analyzing. Anybody else who doesn't have the problem, I'm happy to provide. I have so, and again, feel free to talk to each other, read the prompts carefully. Should be able to pretty quickly meet condition A. Yes. Basically a way of trying to make it very big. So, but yeah, again, use of equation. So that's a good point. You know, so Max's question is, if we are to think about, you know, look at that first paragraph right here. If you look at this paragraph, It should be only applied in unusual cases. And when Max reads the prompt of the problem, he doesn't see any unusual cases on the prompt of the problem, right? Which tells me maybe you shouldn't apply this warrant, which I've given you as a given, right? You should probably not be thinking about this warrant all the time. But because we are still here learning to apply the warrants, so I'm going to go ahead and apply, and I'm just going to go ahead and ask you to apply it anyway. Even though in the scheme of things, in the real world, maybe this is not the warrant you want to apply to this situation, because I'm not sure if I see any unusual situation here. So you're right about that. But I'll still go ahead and apply it. Yes. No, so there is no hard and fast, but it's, it's something that, you have to decide based on your judgment. Yeah.
Have to be like at the intersection, it has to be like a neighboring land use, right?
Yeah, so no, I'm not. So this is like, right as you exit the office complex, right? So
it doesn't have to be actually at the exit.
no, yeah, it doesn't quite have to be at the exit, but where from an office complex, you expect a lot of traffic, like, gonna feed. And that's why, if you go a little bit, even a little bit further out from that location, if the routes have already been segregated from there, so that you won't see any major traffic from that facility. So then, the criteria gets watered. I mean, the need for this type of a signal warrant application gets even further reduced. So we don't worry about that then. But for the sake of our class right now, let's assume that we have to actually apply this warrant and we have to kind of do the analysis. So let's do that. Yes.
In the case if it's like an office, where if it's like one of those unusual case facilities, wouldn't we just get the signal as part of warrant 8 while it's being developed and during trip generation model?
Possibly, but it could be that, so the question is like, why there is another forthcoming warrant 8, that's road network warrant. That's basically is to take care of these types of situations before they occur, right? So if there is a new office coming up, would that be taken care of? For my part, possibly, but sometimes it could happen is that there might have been an expansion. Maybe they hired more people since then. So there could be changes in situation, change in context that might have come in, or maybe the background traffic has increased. So maybe the office park is at the same capacity that it used to be, but now there is more background traffic than there used to be. So now the peak hour combined traffic has gone up. So that could be another situation. But again, so yeah, for the sake of this discussion, let's go ahead and apply this warrant. So condition A, you should be able to tell right away that that's not meeting, right? It's based on the delay, because it says you have to have a delay of 4 vehicle hour delay. But if you look at the data from the problem, your delay is only 3.5 vehicle hours, right? So that's the problem. So that's not going to work. Let's look at condition B and see if this is meeting a warrant in condition B. What about condition B? Is there 1 hour where it's meeting the warrant? I don't think I saw that, so probably not, right? But to me, it did not meet the warrant on that condition either. So because the entering volume has to so basically you have to look at the 4C3, and you have to see in 4C3 figure, does any of these things lie above the numbers? So I guess that's not the case here. So because the major and minor street volumes, and again, for example, if you assume 70% factor, then there are possibility that one of these hours might exceed, right? So if you are, again, we last time we decided that we are going to apply that 70% factor, then you have to stick with that the whole problem. But you just have to pick that, whether you're going to, in any of the you can't do like, okay, in warrant 1, I'm going to pick the 70% condition, but in warrant 3, I'm not going to. So just, keep your analysis sort of consistent for the sake of discussion, like, always to say, okay, if I assume the 70% condition, then I'm going to go with 4C2. And if you go with 4C2, for example, this figure right here, then I think you might find some points that are above that, right? No, still not. Even with this condition, 2 lanes or 1 lanes. Yeah, because it's like, those numbers are like 4. Yeah. So only at the actual curve, so it wouldn't exceed. So yeah, even with the 70% condition, it won't meet the warrant. So that's not a warrant. Let's now look at warrant number 5. I mean, so you go back to the next section on this pedestrian volume warrant. And this is again a warrant where, I would say that, because pedestrians are vulnerable road users, and even though I wouldn't call it like necessarily a safety warrant, this is where I would be a little bit less conservative about installing a signal. I would want to maybe install a signal just to take care of the pedestrians. Yes.
Isn't there like a modern understanding that with the Fed warrant that rather than installing a signal, it could instead just warrant a pedestrian
Hawk signal. Yeah, pedestrian hawk signal is another. So again, for all the signals, if you want to go ahead and put in a signal, remember we talked about how at the very beginning of this warrant discussion, they say exhaust all the alternatives first. So those will be sort of your alternatives that you have to think about. I know this is kind of a lot to process at this point, and then maybe it's not exactly like, something that, we do it this way and that's the way it is. That's just not the way things work in traffic engineering, right? So there definitely, it's a good point that you could consider a flashing pedestrian signal where pedestrians can push the button and then it turns red. Pretty good treatment there. But again, if the volume becomes too high, maybe that becomes an issue, right? So that signal warrant actually is there for the volume of the pedestrian, right? So we are not going to put in a signal if you're not meeting the warrant necessarily, right? We're not going to put in a signal if you're not meeting the warrant. But sometimes hybrid beacon could solve that problem if you're sort of on the borderline, or even this is the only warrant you're meeting. But I would say that, this is another, even if it's not explicitly a safety warrant, right? It doesn't say, it's related to safety. But this is, again, I would think that, I would want to maybe err on the side of maybe going with some kind of a traffic control availability than not. Because again, pedestrians are vulnerable road users. So let's see, for our problem, do we look like we're meeting a warrant? So look at the pedestrians warrant, please. See, do we have enough data on the pedestrian? Did we get enough data on the pedestrians at all? So this might happen, right? So there might not be enough data for some of the cases for the pedestrians. So there is collision diagram. I see the peak hour pedestrian data, but not even peak hour pedestrian data. So I don't even see pedestrian. Do you see pedestrian data here?
on the first page.
On the first page, let's see what it says. Fewer than 25 pedestrian crossing during any hour of the day. So what do you think that is? What does that mean? That means, are we going to meet the warrant? No, we're not going to meet the warrant with less than 25 pedestrians every day. So again, if you're worried about safety, consider pedestrian hybrid beacon. That's a good idea where you could expect pedestrians. So giving them the pathway is great. So considering those things would be useful. So exhausting all the alternatives. So let's see what it says here. Intersection or mid-block crossing. So this is and then 4C6 is available too for us. 466 may be used for 4C5. So again, this is like that 70% condition that they're interested in. And then 4C8 may be used in terms of 4C7. So again, they give you some outs, but again, in this problem, that won't be an issue. But again, you want to be able to read and make sense of these, right? So just make sure that this is all making sense to you as you read through it. Now, this is a statement that this is the kind of thing that hopefully will change. I think they are going to change in the future MUTCD, and I'm going to zoom in here a little bit more so you could see. This is the kind of language that a lot of sort of modern traffic engineers don't like about MUTCD, right? What do you think is my problem with this, right? So what do you think is the issue here, right? Any thoughts on that? Anybody? Do you anticipate any problem with this at all? Yeah.
Basically, that just encourages jaywalking.
Yeah, it encourages jaywalking because by law, it prioritizes vehicle movement quite a bit, right? So, and I'm not even like, so this 300 feet, okay, fine. Like, you want people to be able to walk 300 feet in either direction. That could potentially be a longer walk for folks. And then, and by putting in that last part of the sentence, unless the proposed traffic control signal will not restrict the progressive movement of traffic, that just sort of is a language that is kind of giving an indication that now you're prioritizing vehicular movement by a whole lot. And that's something, you have to be careful about prioritizing, especially in this day and age. Yes.
I do know like there is the issue of putting traffic signals too close to each other where it's a safety issue for you.
For rear end collision. Yeah.
They might confuse one light with the
one
other.
light with the other. That's absolutely right. So yeah, so that's right. So yeah, so 300 feet is sort of a big threshold. 300 feet should be okay. But yeah, you have to be absolutely clear about, and then if you put sometimes, we have to put two signals close to each other. And then we have to make sure that the two lights are going in a way that is a forgiving environment. So so a lot of these issues that we're talking about, like if the two lights are close together and you don't know if the drivers are going to see either one of those, then you want to make sure that the way they're timed in a way that they don't cause confusion that leads to safety issues. Right? So that's another thing to note there. Okay, so let's look at this 4C6. Yeah, if you look at the option here, the criteria for pedestrian could be reduced by as much as 50%. And again, remember, this is when I talked about in the slides, when we mentioned the data that you're going to collect. I think we talked about this a little bit. What type of data is necessary? Yeah, pedestrian volume during peak hour, note elderly and disabled. That was exactly, this was done for this warrant. Thank you for pointing that out. So this is the option. If you're expecting slow walking pedestrians, you can then say, okay, I might have to, be worried about this. And again, there's no indication of that in my problem statement that I talked about. So I'm not going to worry about it, but something to think about as you're analyzing your data. Like if you had a lot of pedestrians, you had slow walking pedestrians, then you could reduce it by 50%. That's pretty, I think, good that we should have that. Now, school crossing warrant. School crossing warrant actually is pretty similar to the pedestrian warrant, but it's about school crossings. So this is not the figure. These 4C6 and everything are for the pedestrian warrant 4. But warrant 5 discussion begins here on page 445. Right? The school card, again, this is the 300 feet language, which is fine, but maybe, you're talking about other remedial measures, pretty important. See if you can provide all these, grade separated crossings and all that. The warrant itself is like, it's pretty similar to, so if you look at the pedestrian warrant, I want to. Frequency and the adequacy of gap in the vehicle stream as related number, size of group of school children and established school crossing across the major street show that the number of gaps during the period when school children are crossing is less than the number of minutes in the same period. So let's say, so this is kind of convoluted to write it. And there has to be 20 school children crossing during the highest crossing hours. So that condition is pretty easy to meet for most schools, unless it's a very, sort of special education type school. But I think in most cases, you'll meet that last part. But here it's a convoluted way of writing and saying, okay, if you don't find 30 gaps, when the school children and number of minutes in 30-minute period. So if you have, if you have 60-minute period, you should have 60 gaps. But I don't think the school traffic persists for 60 minutes, right? School traffic will typically persist for, let's say, maybe 20, 30, 40 minutes or something. So then you're basically, that's the number of gaps you need to have. Otherwise, you need a signal. at that location, right? So something to keep in mind. Number of adequate gaps, you need the adequate gaps in the traffic stream. So if it's a 30-minute period where the school activity is in the area, then you need 30 of those gaps within that period. Okay, so you need 30 gaps at least, so that school children don't have to wait more than 1 minute on average, right? So that's the most important thing. And yes, yeah. So maybe when the bell rings, and maybe 2, 3, 4 minutes after that, you start your period of school activity, and then maybe in next 20 minutes, 30 minutes, depending upon, how big the school is, that's the amount of time it'll take. So, so let's see, this is the school children. Yeah, so there are some things that you have to make sure that you take care of. Install in a non-intersection location, like a mid-block crossing. Then should be installed at least 100 feet from side streets or driveways to make sure that, people are not turning right into it and they can still see the signal and stuff. So those are the conditions that are there. So anytime, these warrant things, always a good idea to kind of give it a good read before you do anything else, just so you know that, what all things you have to take care of as you're reading through it. Yes.
If it's static case like that with the block crossing, not designating crossing there before, how would you, how does it decide? If that happens, my own city, crossing there before, is that just like a random case?
So if I'm understanding your question correctly, what you're trying to say is that, what if you're not meeting this condition, this 100 feet condition?
Or the number of crossing conditions that in the warrant, because there wasn't crossing there before.
So what you're describing is that, there is no existing demand because there is no crossing.
Yeah, but then once
there would be. Yeah, that's a great point. Yeah, do you want to say something first?
I was just gonna look for an answer, probably because they looked at it in a safe route to school study, which folks has different parameters, or it's a different focus from, I guess, traffic operation standpoint.
Yeah, so that's a good point, right? Like, it's an old joke. Like sometimes some people will talk about how, we're not going to build this bridge on a river because we don't see people trying to swim across the river a whole lot, right? Because that's the same idea, same point that you're making, is that because we don't have the crossing. But typically, what you want to do is in that location is that where the traffic is actually going. And again, if the kids are having to go a whole lot farther, and if you start to see even a few kids sort of jaywalking, then yeah, I mean, I'll probably consider sort of a roadway network warrant for that, like, estimating like sort of future condition, right? It's if there is, for example, so that'll be one way of justifying the traffic signal there. And then maybe having a crossing guard at that location too, like just having some temporary crossing guards, helping the students cross across, near the school. But I would be very interested, like maybe after the class, if you could show me the map of that location. So, but they did decide to put in a crossing there. Is that right?
It was a while.
Right.
Wasn't like an official crossing signal playing between like median accessible walkway.
Right. And then, yeah. So again, those are the kind of things that you wanna do anyway, right? So I think what you will do is you'll probably start off as a traffic engineer, and again, signal is sort of your last resort, right? So what you try to do is, okay, I'm going to install where I anticipate I can put in a crosswalk there, especially obviously if I'm away from the driveways. And I'll put a crosswalk and try to use my my crossing guard at that location with the stop sign and all that, make sure people can cross. And then hopefully there will be enough people coming in that can help me sort of justify the pedestrian crossing signal, where I'm not jeopardizing the person who is standing with the stop sign and all of that. And again, this is something that, we have to do. It's hard to do these things when your speed limit is 45 miles an hour. You won't, it doesn't make sense to put in, ask a crossing guard to help there with a pedestrian crossing. So you have to be, if you're putting in a pedestrian crossing, those zebra markings, pedestrian crossing marks, then yeah, you want to probably first do the work of sort of somehow bringing down the speed limits and bringing down the speeds overall. And then obviously on the school zones, you do have lower speed limit when children are present. So that crutch is there. But again, what's the level of enforcement? What's the actual number of people with compliance rates with those speed limits become pretty important at that point too. But yeah, we obviously have that speed limit of 20 miles per hour when children are present. That should kind of give you an indication or some justification for first putting in the crosswalk with somebody helping it with the student, and then hopefully that creates enough momentum at that location to maybe do a signalized intersection at a later date. So coordinated traffic signal. This is something, if you already have a coordinated signal system, but now there are one or two of the driveways where there are a lot of right turns or left turns happening, and you don't have, and that's causing a problem. So that could be a traffic signal. But again, you have to make sure that the coordinated signal should not be applied where the resultant spacing of the signal would be less than 1,000 feet. Right? So if the resulting spacing between traffic signals turns out to be less than 1,000 feet, you shouldn't worry about this signal. But if it's more than 1,000 feet away, and then you're seeing a lot of merging from those driveways and stuff like that, you can try to start to think about signalizing that driveway. Yes.
So like an example of a coordinated signal system is where you have traffic lights. You have two traffic lights, and in between them on the corridor, you have an always stop. And
yeah, always stop will be terrible on a
you would be the warrant to replace the always stop with the traffic.
Yeah, definitely. But in a coordinated system, you probably don't want an always stop anyway, because then you don't know what speed you're gonna use then, right? Because maybe a two-way stop could be converted into a traffic signal that way. Because always stop, yeah, obviously in a coordinated signal system, that all depends on the whole idea is that once the stream gets moving, it keeps moving throughout. And there is some talk about sort of optimizing that stream for bicyclists, for example, and there have been some implementations of those. So if you optimize those for bicyclists, you can actually encourage drivers to even slow down too, because then if they know that this is optimized for not for 40 miles per hour, but maybe 18 to 20 miles an hour, then the drivers would be encouraged to drive slower as well. And that's where they'll get all the green. So there is some talk, there is some action. I think there are some real world examples of optimized signals or coordinated signals with the, and then in this class, we'll learn a little bit about optimizing the signals as well. So, and then this is again, if one of the following criteria are met, so you only have to meet one of the criteria. And I talked about platooning. Did I talk to you about platooning? I think no, I was talking about maybe 222 class about platooning because they're going to do a spot speed study. But platooning is basically when vehicles sort of kind of bunch together, so that have similar speed, they kind of move together through the traffic stream. If the two signals are too far apart, the platoons get split up because now some people drive slow, some people drive faster, and that leads to split up of the platoon, and that's not good for coordination. So that we try to do that. And if we see breakup of platoons happening, then we want to provide a signal in the middle so that we can maintain the traffic platoon. And on a two-way street, adjacent traffic control do not provide necessary degree of platooning. Same thing. You're basically looking at that progressive, movement of vehicle at an appropriately chosen speed. And in the class, actually, in the module 2, in the next module, we'll learn to at least think about how do you coordinate the system, what are some of the ways of coordinating, and what does the signal timing look like for that, and how do you coordinate actuated traffic signal too, right? So all of our signals are going to be actuated, but then we pre-time them for the peak hour condition, and then we just run them on a pre-time basis too. Okay, the next warrant, very controversial in the ways you should. This is controversial because, this number right here, 5 or more reported crashes. And basically, this type of the crashes that are susceptible for improvement by traffic signals, those are your T-bones, right angle crash or left, somebody turning left, and somebody just bumping into it going through. Those crashes, 5, that's a pretty high number within a 12-month period. That's pretty high to me. I think that basically when you're looking at 5 of these crashes, you're probably talking with newer cars, maybe not as many, but at least when these warrants were written, I would say you're talking at least 5 people dead on average. Like, those types of crashes are pretty severe in nature. Yes.
Our prospect, the IT cites the history of the 5 reported crashes into 1935.
Right. Goes way back there. And again, our speeds were way lower back then. So maybe 5 reported crashes was okay. But now we have very fast accelerating cars. So even if somebody has just started accelerating because they saw the green light and somebody's just sort of still running the red light, but not in a very egregious way, they're just sort of speeding up on a yellow, even that could lead to pretty bad outcomes there. So I think that number seems pretty high. And then, they still kind of have a lot of couching language there. And, I think this is the warrant where I want to be less conservative and hope, and I know because it's not out yet, so I can't say for sure, but I'm almost certain that, this warrant will become a little bit less conservative in being able to put in the traffic signal as we go forward. But as it is right now, look at like how conservative. You have to meet all 3 of the following criteria, right? And you have to document adequate trial of alternatives, warning people for a stop sign so that they don't run it, all that. Yeah. And then, look at 5 or more reported crashes for each hour of the 8-hour day, given in both of the 80% condition. So you still have to meet the traffic volume warrant as well. And then look at the pedestrian traffic is not less than the 80% of required specified in the pedestrian volume current. So a lot of sort of hoops to jump through for a safety warrant, and given that we say safety is sort of our priority, right? Again, we don't want to install traffic signal willy-nilly, but maybe the safety issue should be corrected before it gets to be so bad. Again, for now, when we are applying these warrants, we're going to apply it as they're written. But, as an engineering judgment, will we look out for the new warrants as they come out and kind of start thinking about, okay, what can we do to apply it? And again, it kind of leaves a little bit more leeway if you have higher speeds and so forth. And so let's look at, let's try to see if there is enough information for us to evaluate the safety warrant here. So let's go ahead and evaluate the safety warrant. Are there enough crashes that are amenable to be improved by traffic signal in this? So rear ends are definitely not that. So you can exclude a rear end. Rear end are not something that gets taken care of by traffic signal. In fact, rear end makes it worse. I mean, the rear end crashes become worse. Traffic signal makes the rear end crash problem worse. So what do you think? Any thoughts, any questions? Talk to each other if you need to. Feel free to do that. Are we meeting the pedestrian or the safety warrant?
Because it is really standard around the
Okay, questions, thoughts? So let's think about how many crashes are actually happening if you look at the sheet there. Look at your collision diagram. How many crashes are actually happening here? That are amenable to be improved by traffic signals. So we talked about those things, right? So we talk about what crashes are amenable to be improved by traffic signal here. Right angle, left turn, head on. So tell me which of these are amenable here. Are there enough in 1 year period? No. Or which ones are, how many do we have? One or two? So look at, there is no left turn head-on crash, right? I don't see any left turn head-on crash. I see a bunch of side swipes, which are not exactly amenable by. I see two angle crashes though. So if I look at that sheet, I see two, not two, and the two T-bones, right?
Is that supposed to be the
Yeah.
or a number of crashes? But then
No, that's crash, the number of crashes, two.
so why would you have why would you have the two rare ends in the same location?
Yeah, I think it's the question. I think
So let's see, number of crashes. Let me see, do we have a number of crashes here? No, I think those should be number of crashes. I'm not sure why do we have. Oh, so no, actually this has total 6 crashes. And then each of those crashes is drawn like that. So yeah, there are 2 rear end crashes. Yeah, I'm sorry. Yeah, you're right. So let's look at the data here. Collision diagram, do I have it here? Okay, so I don't have the data here. Okay, so yeah, so if you look at the chart that I shared with you, the problem statement, you will see that there are 6 different crashes here. 5 and 6 are rear end crashes. 1 is a side swipe. 4 is a side swipe, and 3 is a side swipe as well. And then 2 is a right angle crash. So actually, there has been only 1 crash. That means you're not meeting the safety warrant at this location. Okay? So yeah, sorry. So if you look at that chart, you have to be careful about, like, I just, for some reason, I thought these were the numbers, but no, they are basically describing the 6 different crashes. And the collision diagram actually just describes those things. Unless there is so many collision diagrams that you can actually represent it, that becomes an issue. But in this case, it's just 6 crashes, different crashes, and they're just drawing them out in each location. So that's what it is. Thank you. Yeah. Okay. So safety warrant is not met then. Let's look at the warrant number 8. Warrant number 8 is about roadway network. So roadway network warrant is existing or immediately projected at least 1,000 on a typical weekday that meet one or more of warrants 1, 2, or 3 on average weekday. So meets one or both, right? So you only have to meet, finds that common intersection of 2 or more major routes, meets one or both of the following criteria. A major route is used in a traffic signal warrant. So how do you define major route? This has to have following characteristics. So part of the street or highway system as a principal road network or through traffic flow, rural or suburban highways outside entering or traversing a city, major route in official plan. So this is the idea that, this is the keyword here, immediately projected. So that's what we're after here, is something that's going to happen in the future. Again, we don't have any indication of that here in the problem. So we are going to ignore this. And so not worry about this at all. And then let's look at the last one. Last one is not applicable either in this case because the nearest railroad crossing is 2 miles away. If you look at the problem statement, so I'm not going to worry about it. But this is something that you have to think about. And I think this may have been the warrant. I mean, we have enough traffic here, so maybe not. But if none of these other warrant met, we would have looked at this warrant to put in a signal on Foothill and California, because we are at that close location on Foothill Boulevard. But again, that will probably meet all the other warrants as well. There's such a high traffic there, so we wouldn't worry about this. But if you look at the standard for this is to take care of the railroad crossing. So when you say grade crossing could mean a lot of things, right? Grade crossing could potentially be, all intersections are grade crossing. But here we're talking specifically about the word that's not mentioned here is railroad. So it's a railroad crossing we're talking about. So warrant 9 is about railroad. The intersection near a grade crossing signal warrant, look at when none of the conditions described are met, but proximity of the intersection to a grade crossing on an intersection approach controlled by a stop or yield sign. Okay, so this is to show a diagram. This is what you're looking at. You have the major street, you have the minor street on grade crossing. Or you're talking about this type of a situation. 2 or more approach lanes at track crossing. And then you have 1 approach lane at track crossing. Okay, so 2 different conditions, whether you have 1 approach lane or 2 approach lane. How many do you think we have on Foothill Boulevard? What's the condition there, right? We have. So you think about if you've driven through the Foothill Boulevard, how many roads are approaching the railroad crossing? How many lanes are approaching the railroad crossing? In each direction, right? How many approach lane at grade crossing? It's only 1, right? Or 2? 2 on each direction. Yeah, so there is 2 on each direction. So if you were applying this warrant at that location, you're basically dealing with this situation right here. Okay? Yeah, you are in fact dealing with this situation. So, and then again, the chart is then based on how big is this distance D from the stop line 6 feet away from the railroad crossing right away here. So this is your D value. D is 30 feet. The thresholds are going to be very low for you to put the signal. Okay. And where are you putting the signal? So this is another thing that you have to think about. We're not talking about putting a signal proximity to the intersection of a grade crossing on an intersection approach controlled by stop or yield sign. So if you think, just want to make sure that you understand that we're talking about putting a signal over here. Okay, this is not, obviously we want to make sure that, our signal our crossing itself is protected. But the question is, do we need a signal right here? Yes.
Just like asking or checking sure, this is done to primarily to make sure that that it can be synced up with the preemption as to make sure that there's not a situation where a vehicle stuck on the tracks because.
Yeah, definitely. You want to make sure that this is not the case. Like you want to make sure that, the queue near here, the queue on this low rate. So the idea is that, yeah, exactly right. So obviously you want to take care of this, but you don't want the queue to be backing up over here, and then people are getting stuck here. Or you don't have a situation where this lane is backing up and it's causing problem over here. So yeah, definitely this is going to be a problem if your timing is not clear. And if you do decide to put in a signal based on this warrant, your timing has to be making sure that people are not getting stuck here at all by any means, right? And again, you'll make sure that do not block intersection, all that signage and everything will have to go along with that. But yeah, that's exactly right. You want to make sure that there is no vehicles getting stuck over here. So, and again, you could see that the threshold in this case are going to be a little bit higher here. So if you look at just one lane, and if you're talking about a 2-lane, so if you have a 2-lane, then this is what the thresholds look like. The thresholds could be as low as for 50 feet, the thresholds are like 150. Even 150 will meet the threshold here on a 2-lane approach. But if you go back here, 150 will still meet it. But let's look at if the D is a larger number, the D is something like 130 feet. So if you look at D and 130 feet, 200 and 250 will meet the threshold. Yeah, and even a lower number will meet the threshold on a 1-lane, because on 1 lane, you're basically backing up the queue quite a bit. But do you see that? The threshold go down when you're talking about 2 lanes. Does that make sense? Right? Because now the traffic can divide itself over into 2 lanes rather than just kind of being in a single lane. So the requirements are a little bit less conservative, or should I say they're more conservative when you only have 1 lane. You go ahead and put the signal in at a lower threshold there. Okay. So that's and then again, you're looking at the same thing. You're looking at the chart and see where the points fall in this case as well. And just sort of looking at where the points are falling. If they're falling up or below the curve, if falling above the curve, then you consider putting a signal in. Okay. Again, reading through the warrants would be carefully would be absolutely critical. And then these measurements would be critical, but in the classroom problems, they will be provided to you, so you don't have to worry about it. Again, reading through the language specifically as you're solving the problem would be very, very important. Yes. So proximity to the intersection of a grade crossing or an intersection approach, controlled by stop or yield sign. So yeah, so I think what you're talking about is that these ones, right?
Those are stop.
Yeah, those are stop. Yeah, no, I think this could be whatever. Even with a crossing guard here, I think you're talking about. I know you're talking about the signal over here, putting in a signal over here, because you're talking major street volume and so forth. So yeah, you're not talking about what you're going to do here. You're talking about what you're going to do over here. Questions? Other questions? Yes.
What would warrant a pre-signal?
Pre-signal.
Like basically, so it's already signalized the intersection, but then there's another signal, let's say on the minor before the crossing.
Before the crossing means
Like yeah, for that.
Oh, so for here, like if you need a signal, yeah, so those will be sort of depending upon that sort of depends on the rail counts. I think how many cars, rail trains are you passing? And then you would basically look at those, I think, from a delay perspective and see. But here on at-grade crossings, you always will provide some kind of signal to get the right of way. So those will always be there. I think the question is, you always would want to protect those. So are you talking about a signal like even upstream there? Or are you talking about right at this location?
Oh yeah,
at the location, you'll always provide something. Like, if you're having a railroad intersect with a roadway, you want to always, you're not going to just leave it. Yeah, you're going to put in a signal there, preferably like a closing gate and everything. So those would be very rare if you don't put anything like that. So, do you have a question?
Oh, is kind of comment on that? Like, if you're never going to get like a situation, you're basically never going to get a situation where you have to, I guess, for a new road over railroad crossings, and the preference now is make it, do grade separation.
Yeah, I mean, grade separations are fine, but I think in San Luis, I know of a few locations where there is no. So right now we have one near campus, right? And then we have one on what is that? Orchard Road, between Broad and Johnson. There is
Great.
no, that's not grade separated. I pass by that location pretty frequently. I wonder if there is another one. No, I think that's it. At least in the part of the city that those are the two that I know. So yeah, no, they would. Yeah, so maybe there is a preference for grade separation, but you would still find it, and then you'll always put, especially inside a city, you'll always put in a gate there for sure. Yeah. So we're talking about the signal warrant for this location, not for this location. This is I think this is any kind of railroad track. You're talking railroad track. I don't think it covers tram. This is not tram, but you know, so this would cover, I think, even light rail or heavy rail. Okay, so this is sort of the signal warrant discussion that I wanted to have. One thing I want to talk about, because I did extend the homework deadline. Do you wanna, like, anybody have any questions for the homework problem? I will have some office hours on Tuesday before the class. If you want to stop by there, it's due on Tuesday, but I hope you're making some good progress. Any questions anybody wants to ask about the homework? Yes. So urban arterials would be sort of, so remember the functional classification that we talk about. And so the question is, what is an urban arterial, right? So is that the question, right? Yeah.
Yeah.
Yeah, so let's go back to the question. I don't remember it off the top of my head. Let's take a look at. So we're talking problem set 1. Yeah, so AADT for a section of urban arterial is 40,000 vehicles per day. What range of directional volume? So we're asking for range, right? So if you go back to your notes for the first class, there was something about whether it's an urban area or rural area. For those, you had different factors, K factor and D factor, that you could apply to get the daily traffic. So arterial would be sort of, you know, this is like the urban arterial would be a road that connects a bunch of rural collectors. So it takes the traffic from a bunch of collectors. So a bunch of collector streets would be meeting to it. So remember, the functional classification are like, you know, you have the minor street, the neighborhood streets type of things, and then you have the collectors, and then you have the minor arterials, and then you have the major principal arterials. So arterials, kind of urban locations behave in the same way in what happens to how much of your traffic occurs during peak hour versus how much occurs during off-peak hour. So if we go back to, let me go back to the notes here from our Canvas page. I think this was in the first lecture here, traffic engineering elements. Did we talk about it in the next class? Okay, second. The reaction time. Or was it lecture 2? Yeah, this is actually lecture 2, sorry. So go back. Studies, I think. Yeah, this is a volume study. This is part of the volume study. So this is part of lecture 2 here. Yeah, so I'm referring to the Astro table. That's it should be here, right? I think we showed it here. not the C. Yeah, so this is the one. So what I'm talking about is like, it's an urban arterial. So you can almost think of that as like, it's probably gonna take in traffic from a lot of different characters. So if you're wondering whether you should use the radial route or the circumferential route, I would probably pick radial route here, because unless it specifically says that you have to use the circumferential route, I would pick the radial route, because an urban arterial implies that, this is in the heart of the city, probably correcting traffic from a lot of major arterial. And then, because I'm asking for a range, you'll kind of apply the minimum factors from both sides and maximum factor from both sides, and that'll give you like a lower limit and an upper limit for the DDHV. So that's what I'm looking for. Right. Other questions? Yes. Number 2. Yes. So this is interesting, right? So we talk about friction factor. There was a formula in our first class when we talk about this. It did not incorporate F, but yeah, that's kind of what I want you to think about a little bit. Let's think about this. There was something about the acceleration and deceleration factors. Sorry, I'm going to go back to it. Oh, I thought I had a formula in here, that stopping distance formula, no? Can we do the braking characteristic somewhere? Reaction time. No, not that. I thought I had a formula in there too. No. Oh, I don't know. Let's see. There was a formula that talked about how, the two. Did I not have it on the slides? Sorry, I don't know what I'm thinking. Now this is the next one. No, this shouldn't have it. I thought there was a formula that I showed you guys. This lecture? Lecture 1, slide 43. Okay, yeah, that's good. 43. Let's look at 43. Yeah, I know it doesn't have F directly, so that's what I want to talk about. Yeah, this is the one. I don't know how I missed that. Okay, so the question is, all right, this one doesn't feature. So if I'm asking you to apply this formula in that problem, and this is sort of, as I told you guys, so this is the friction factor that I'm assuming, 0.348 is the friction factor F. This is the standard formula that we use, where F is equal to 0.348. It implies a certain deceleration rate, which is 11.2 feet per second square. Okay, so that is the friction factor F. So if you replace, when you're solving the problem, your friction factor that's given to you, then you will be able to derive your speeds. And then you'll have to apply this 2 times, because you're basically in 2 different areas. So there will be some distance of travel that's going to happen on. So you'll have to kind of do it in 2 stages. You'll go from initial driving speed to the first application of brakes, where you have the reaction time and all of that. And then once you get there, there will be the second friction factor. So your initial speed would be there, but you're already braking. So you won't worry about reaction time at that second stage. So there is a lot of thinking involved, but I think it'll become easier if you think of this 0.348 as your friction factor. So replace the value 0.348 with whatever value that you have been given for that type of surface. So this formula is actually F, this is what you're taking F as. And AASHTO uses this value of F because it translates into the deceleration rate created by the vehicle of 11.2 feet per second square. Okay. questions, more questions? If there are no more questions, we can stop here because in the next class, we're going to pick up discussion on a new module that won't be part of your test, test one. That won't be part of your test one. It will be part of your test two. But yeah, so we'll pick up discussion there. And yeah, so feel free and make sure that you are making some good progress on homework. If you can't meet me on my office hours, you can schedule a time to meet with me on Monday. That's fine. Just let me know when you need to meet, and then we'll go from there. If there is any questions or anything, please let me know. And then, yeah, we can always set up a time to meet using the Calendly link on the office hours. Okay. Otherwise, I'll see you Tuesday. Thank you. Yeah, I'm always curious. Yeah. And this is another thing about signal warrants. Just one last thing I want to say. Talk to a traffic engineer. Yeah, everybody has a warrant story, right? Everybody has, some. If you work long enough, you always have a warrant story where you had to either put in the signal or not put in the signal, and maybe they had some good sort of, play around with that at the public council meeting or whatever.